Kia ora and welcome to Bustaz. Just a quick video to show off a couple of cool toys that have arrived from AliExpress. As you probably already know, I love AliExpress. I buy quite a lot of stuff from China. It's very reliable because of the fact that you're dealing through AliExpress and not directly with the suppliers until you've actually got it. The people who have sending it to you don't get paid, and if you declare that you didn't get it, or that it wasn't what you were expecting, or that it's broken, they'll either sort it out quickly because they do not want bad feedback, or they just don't get paid and you can get your money back from AliExpress, being the company you dealt with. I guess Amazon's kind of takes a similar approach, but price-wise, AliExpress is pretty damn hard to beat, and often includes free delivery to wherever in the world you are. But before that, I also bought this locally. If you have a look at it up close, the detail in it's really quite neat. It's just a fire poker. It's made by a travelling blacksmith. He goes to gypsy fairs and home shows and stuff. Really like his work. He's actually got a few things that he's made. Some handles for the bus and so on. Anyway, I digress. In New Zealand, to do your water tanks, you have to have grey or combination of grey and black tanks with a greater capacity than your freshwater tank, and that's simply in order to get self-containment certification, which enables you to park in a lot more places. You can actually have a smaller waste tank than a fresh tank, but in order to do so you need to have it monitored, which means you need to know how much waste, how much water's in it. Now the kits that do that are very, very expensive, so you know, like probably the best ones sort of upwards of about $700 or $800 just to know your water level. So I've come up with these. Now this is a real simple non-contact, it'll only work with plastic or non-metallic tanks, but it's a simple non-contact fluid level measuring device. So let's say you've got a tank and you had one here that would sense when it's pretty much empty, one here would sense that it's half full, and one here would sense that it's pretty much full. So I've bought 4 of them, and they're $9 each, which is pretty bloody hard to go past. So they're I can't recall if it's PNP. It's an NPN. It's an NPN sensor. Right now, what it does is it's basically a proximity sensor looking for water, so or fluids. So this is on the outside of the tank, like such. Now when the level of fluid comes up to this, maybe about halfway up it, then it will turn on. This little light will turn on and it will turn the circuitry on. It's a 4-wire setup. Can you see 4 wires? I don't know. Anyway, it's got 4 wires. It's got a ground wire. It's got a power wire. Now that can be anything from 5 volts to 24 volts. It's got a mode wire which determines the output, and it's got an output wire, and the output of course being once it's triggered. So the output can be high or low depending on whether or not you've got the mode wire at high or low. So if you've got say for argument's sake a 12 volt input and a ground, and you've got the mode hooked to your 12 volt supply, then the output will be at 12 volts. That's it in a nutshell. Now I've got 4 of those, so like I say, I could have them sitting in different positions on the tank. So one maybe, I mean, who cares if your grey tank's empty, so I don't really need one at the bottom. So maybe one at half or even 2/3 full, and then one approaching full, and that would cover it for that. And when it comes to the fresh tank, then again, you don't really need to know that it's full. So maybe one that's sort of half full and one approaching empty. So for $40 odd worth for 4 of these, I've probably got enough to monitor 2 tanks. I thought about buying more, but I also like a lot of things with AliExpress. I want to try them first. These come with absolutely no instructions, however, on the seller's website it explains how they work. Maybe I'll hook them up to a little Arduino board or something like that, to give me a more interesting output, or for the cheapest, simplest setup, I would simply use them to turn on LEDs. So I could have an LED that says this tank's getting up there, and another LED that says this tank's actually quite full and you need to empty it out. Likewise with the fresh tank, I could have an LED saying right now you're down to half, and another one saying yeah, you're getting pretty empty, go and get some more water. Of course, if they're a similar size, if I've got, for argument's sake, a 200 litre fresh tank and a 200 litre grey tank, then, you know, other than the fact that we'll be consuming water as well as putting it through the system, when one happens, the other will likely happen anyway. So that'd be pretty easy. Alternatively, I could use something like an Arduino board, drive it from that, because it'll run at 5 volts, so 5 volts input and output will be fine, and could literally use that to, you know, make more of a fancy graphical gauge interface. I'm not sure that there's any value in that. Next cool toy. Now I actually already have a battery monitor. It was about $30 or something like that from eBay, and it's not bad. It has, I've been using it. If you've seen my prior video of a little solar generator I built, you'll have seen it there, and it's quite good. I'm thinking I want something that's just a touch friendlier. I'd like to have it Wi-Fi, so I'm not limited to how far away from the batteries I can have it. Although of course, you know, you could extend the wires and stuff, but they're a pretty sensitive piece of equipment. So the volt drop across the cable to the unit could be a significant factor in how well it does it, and how good a job it does of measuring the flow of energy. So I bought another one. Now this one here is what's the brand? Like everything Chinese, it doesn't actually tell you the brand, and guess what? It's come with a user manual. No, literally a user manual. But aside from the really terrible spelling, it's actually not bad. It actually does a reasonable job of explaining, you know, the functions, how it all works, what it's capable of. There's its kind of specs there. What I like about this is it's got a really nice, it's got quite a nice setup concept. So it has a shunt built onto a box with everything in it. So I'll take this off. So the shunt's there, and it's actually literally mounted on top of all of the electronics required to run it. So what that means is there's no volt drop between this and all of the measuring electronics and junk. Now it can be wired up several ways. It can be powered separately. It can handle up to 100 volts, I think, and up to 300 amps. Now I went with the, and it's a nice little unit, nice setup. A little odd that these terminals stick up outside of the box slightly. Seems a little crazy. Since you'd be kind of trying to protect them, but bearing in mind that this is on the negative, on the earth side, so if this should come in contact with earth, it's no big deal. With ground, it's no big deal. It has a USB output, so you can hardwire it to the head unit, but all the real hard work's done here, and it's simply telling the head unit what's going on, or the head unit's telling it what to do, because it's quite programmable. So it came with a USB cable and a power cable to power the head unit. And the size of those wires will give you some sort of indication as to how little power the head unit requires to run. Now, the head unit itself is Juntek, that's what it is. Juntek, yeah, that's what it is. The head unit looks like this. When it's turned on, it will look, well, it's actually quite programmable, so it doesn't have to look like that, but it'll look more like that. Now, what I quite like about that is it's got kind of, well, I like the graphical battery display. Now, what this is doing, the thing with monitoring batteries is that they, you can't just look at the voltage. A 12 volt battery is fully charged at 13.6 or something. It's fully charged at 14 volts. Does it have any more charge at 14 than 13? It's kind of flat at 12, but it's not really a linear, it's not really a perfect measure of how much energy you've got stored in the battery simply to look at the voltage. You can kind of, you can get an idea, but the best way to measure the amount of energy you've got in a battery is to know how much it can hold. Now, batteries have a capacity. You can buy, for argument's sake, a 100 amp hour battery. And that has 100 amp hours of capacity from fully charged to fully flat. Now, if it's a lead acid battery, you might only want to use 20% of that, so you might want to go from fully charged down to 80%. Now, what we know from a mathematical point of view is that's 20 amp hours, that gap between there and there. So if you tell a gauge that 20 amp hours is from here to your flat, you've used it all, then you can have a nice graphical gauge like this that says, you're charged, and when you've used up 20 amp hours, you're flat, or whatever it's set at. So you basically you tell it this is empty, you tell it this is full, or you tell it this is full and this is how much you've got, and you can use it as a gauge. Now, the way you then measure that is you measure the flow of energy through this shunt. Now, I don't really want to get too technical on it, but the fact is this is a known resistance. So given a shunt like this of known resistance, by measuring the volt drop across the shunt, I can measure how much energy, how many amps are flowing through the shunt. So that's all pre-built into the electronics of this, and really the guts of it is that this measures amps. Now it's also measuring volts. It's also got a little temperature sensor, so it's also measuring the temperature. and all of these things kind of plug into it, and it's measuring all those things, but its job is to measure amps. So it's measuring the flow of electricity into or out of the battery. So you hook that to the battery, you hook everything else to that, so that you know when you're charging the battery, you know how much charge you're putting into that battery. And if you put in 20 amps for 1 hour, then you're going to put in 20 amp hours. So if you take out 20 amps for 1 hour, you're taking out 20 amp hours. Now, knowing the amps going in, knowing exactly how long those amps are going in for, and you know, in a realistic charging situation, your 20 amp, even if you've got a 20 amp charger, you're not going to put in 20 amps for the whole time. It'll taper off as due to charging profiles and so on. And likewise with loads, you might run a 1200 watt microwave through an inverter off of a 12 volt battery and use 100 amps, but you're only going to use that for maybe 5 minutes, you know. So it's measuring all of these loads coming in and coming out of the battery, and from that it can calculate how much capacity is left in the battery, how much power, how much energy is left in the battery. So that's pretty cool. Like I said, I've got one. I feel that this one will suit my needs better, and I'm kind of hoping it'll be just a touch more accurate. So I'm going to test them both side by side and see. I could run them both. I don't know why, but I could. So that's two cool things that I've just bought. I've done some work, some testing of solar panels and stuff with my other one. I feel that because this one will probably do a little bit better job, that the cool thing about it is this can talk to this with no wires at all. Well, this of course needs a power supply, and that's I think it likes 12 volts. I'm not sure. I have a feeling it can handle more, but I think it likes 12 volts. This is this will run on anything up to 30 volts, I think. It will measure anything up to 100 volts, and it requires, I think, about 30 volts, up to 30 volts to run. So that's going to run nicely at 24. I've got a feeling this can handle 24. I'm not sure. I can't recall. If not, they'll need 12 volts to power it, or USB, which is easy as hell, isn't it? But being wireless means this can be over here and that can be somewhere else. So I've been holding off doing my next level of my next lot of solar panel testing until I got that. I'm quite keen on playing with some different scenarios in low light conditions, running panels in parallel and in series. There's a lot of conflicting advice about how best to wire up solar panels. In some cases people might say that, particularly with MPPT controllers, they can handle quite high voltages, although they're less efficient at higher voltage, and they convert that to whatever you need. And when the voltages get down a little low for them to be efficient doing that, they switched basically to PWM controllers, which, without going into too much detail here, are more suited to low voltages and less efficient overall. Now, there's a suggestion that if you use series wired panels, that will never happen because you've always got higher voltages. However, there's an argument that series wired panels are actually, because of the reduced efficiency from the higher voltages and because of other issues around shading, are considerably less efficient, or get considerably less power out of them. So I don't know who to believe. I've got conflicting advice from some really quite smart people, and some of them are wrong. So let's find out. So I'm going to give that a try. I'm going to use this device. I'm going to hook it up to 24 volts and or to a 24 volt battery. I'm going to hook that to a couple of 250 watt 30 volt solar panels in different configurations and see how it works out. To help with that, I have some MP4, some solar plugs. I've got males and females. These ones are solderable to 10mm squared cable, which is some serious grunty cable, and they assemble together. One's male, the other's female. Now that will go on my cabling, which of course, because of the length of runs across the roof and stuff, will actually benefit from having such heavy cable. And they've got these joiners. These are needed to parallel the panels, so if I hook two panels into here and get them through one output, I get twice the amps, same voltage, whereas if I hook them up in series, I'll get twice the voltage, same amps. More about that later. Just wanted to show you the cool toys I've bought from AliExpress. These of course are also from AliExpress. Really neat things. I've gone for this type as opposed to the Y wired cable, to avoid the bit of wire in between. Anyway, it was meant to be a short video, so thank you very much for watching. Hope you enjoyed it. If you did, press all the buttons, the like and the subscribe. Is it like and or is it subscribe? Press all the buttons, and hopefully that means we'll see you again soon. Take care. Mā te rā.